Cool. So, good evening. My name is Matt Wallace. I am the co-founder of Mockingbird Consulting. We are an Internet of Things managed hosting provider and consultancy. And we have literally this week just launched our product, which is fully integrated farm management, including lots of sensors and little gateways like this and all sorts of wonderful things like this. So why am I here talking to you about monitoring? Well, because for the last 20 years, I've been a systems administrator. And over those 20 years, whilst I've attempted to write code and it's never turned out particularly well, one of the key sources of frustration for both me and the developers that I worked with was that they didn't understand what was happening inside their code base. So this evening, I'm going to talk to you a bit about what kind of things we want to monitor, how we might monitor them. There'll be some example dashboards. I'm not going to do any live demos. I'm not that brave. And hopefully, you'll all go away with this with at least a few questions, even if that question is, what the hell was he going on about? So, how's data different from information? I'm going to go right back to the beginning here. We've got a number, 90. Brilliant. Okay. What is it? Is it 90 stars? Is it 90 people with 90 cows? 90 degrees. Brilliant. Okay, so we've got a qualifier on the data. We've got a rough idea of what it is. But is that a 90-degree angle? Is it temperature? Is it 90 degrees Fahrenheit, in which case it's warm, but, or is it 90 degrees Celsius, at which point, we're close to being on fire? And the point is that when people tend to do monitoring, a lot of the time they follow the Etsy rule of measure everything. And there's a fantastic blog post that's probably getting on for 10 years old now, where Etsy talk about how they monitor their environment. And in it, they say, sometimes we monitor stuff just in case it decides to make a break for it. Now, that's great, but what you end up with is this massive pool of data, and then people look at it and go, but that's too big. I don't know how to understand that. So we're going to start to look at how we break that down. So what do we want to monitor? Who's going to be brave and give me some examples of the kind of things we might want to monitor in a hosting? Say you're running, I don't know, let's go for a really simple answer, a really simple Drupal application. What are you going to want to monitor?
Page response times.
Okay, page response times, that's cool. Anybody else? Yep.
Errors.
Number of errors you've got, brilliant, yep.
Transactions if they're happening, financial transactions.
Okay, cool, awesome. Anybody else? At the back there. Say again? Memory usage, cool, excellent, yes. Uptime, always a good one, that. Be careful with uptime though. As a system administrator, I hate boxes that have been online for more than about 15 days because it means no one's applied any patches and they haven't been rebooted. So having uptime on a web application where everyone's been able to access it without fault for 4 nines, 5 nines, whatever it is you're promising your customers is absolutely amazing. If your systems underneath that have been online for over a year without being rebooted, someone's not doing their job properly. So let's have a look at some of the ones that we've got up here. So security monitoring. Anyone here doing security monitoring with their applications and willing to admit it? You are. Out of interest, what tools are you using to do
that? So there's a custom OWASP tool that we've got built in.
Okay, awesome. So that's doing sort of like analysis of the code base as
we actually go out and deploy this.
Awesome. And some of the rest of you put your hands up as well?
Wazza,
excellent. Really glad to hear that. We're just about to set up a partnership with them. Love their platform.
very simply, we just use like Feldspan and email levels in the jail.
Awesome, good stuff. So you're looking at basically our China and Russia trying to because I used to work for a shared hosting company. We had about 500,000 websites hanging off the back of our cluster, the vast majority of which were out-of-date WordPress, Joomla, and Drupal installations. It didn't cloud my judgment of PHP, honestly. And what we found time and time again was that it was constantly the Russians and the Chinese that were trying to get into these sites to upload the scripts, C99 and all these other wonderful shells that they could use to compromise the platform. What did we do? Well, we just put a net block on the whole of Russia's IP address space and China's IP address space. And if any of our customers said, we're not getting any traffic from China, it's like, no, you're not. Go and find someone else to host you. So that was our solution. I hasten to add, this was about 10 years ago. Things have moved on since then. The Chinese and the Russians have both got cleverer and you start using VPNs to attack you instead. Systems monitoring. We mentioned uptime, we mentioned memory usage, CPU, RAM, disk, all of that kind of thing. We want to look at the application monitoring, and I'll fill in some of these, and we want to look at some user monitoring as well. So from a security point of view, we're looking at the audit trail. Who was doing it, what were they doing, why were they doing it, and how did they do it? And the vast majority of that you should be able to get out of your logs, be that application logs or systems logs. If your application isn't doing audit trail logging of the visitors to your site, please implement it. Do not rely on Nginx and Apache to give you that information, because all they'll give you is a URL. They won't tell you the method that they were trying to call. They won't tell you how deep inside the code they were trying to get. They won't tell you about any kind of SQL injection attacks or anything like that. They'll just say, oh, someone tried to post to this URL. Brilliant, what was the data? Haven't got a clue. System monitoring, CPU, RAM, disk. As I say, there are other things if you really want to get into it. I mean, disk. Most people, you say disk monitoring, they're like, oh, disk space, great. Yeah, no, start looking at IOPS. How quickly are your disks responding? How fast can you write? How fast can you read? Do you need to change your instance type in AWS from a general purpose to something that's got faster IOPS or something like that? Is your storage too fast? Could you get away with a cheaper AMI or a cheaper instance size? Do you really need that X4 large when actually all it's doing is running Traefik as a proxy? Probably not. RAM and CPU. Again, CPU, everyone goes, oh yeah, we'll just look at we'll look at what the loadage, the average is over 5 minutes. Great, but how often is your CPU idle? Are there other things you could be doing with that CPU while it's idle? CPUs are designed to run at about 85 to 90%. All right? You should be thrashing that thing. Absolutely thrashing it. So if you've got data processing that needs to be done, and your front-end web servers are just serving up static JavaScript and they're idle 95% of the time, try and offload some of that data processing onto those front-end nodes. Do it securely. But see if you can get some way of either utilizing that CPU load more, or at least be aware of it, and again, see if you can save money by scaling the instance size down. Application monitoring, yeah, performance, uptime, errors. We've pretty much covered all of those already. There's some great tools out there to do this. Especially errors. People here must be aware of GetSentry.com. Or is it just Sentry.com these days? I can't remember. They keep changing the names. As bad as all the config management lot. But if you don't know Sentry, there's a library that you embed in your code. You can host Sentry yourself, or they'll host it for you for a fee. And it will give you a full stack trace attached to every single error that your code logs. You can drill right the way down through those stack traces, see what the function calls were. Depending on how you've got it configured, you can look at the variables that were being passed into that function call, what the latency was to the database, all sorts of stuff. It's absolutely amazing. And like I say, it is, at the heart of it, open source. So if you want to run it on your own infrastructure, or because corporate policy dictates everything has to be behind the firewall or something like that, then you can do that. Uptime monitoring, Pingdom, Status Cake, all of these external, we'll just connect to your port 80 and make sure that we get a response kind of thing is there. You can start looking at synthetic transaction monitoring, but I'll come on to that in a minute. And then the performance monitoring is not just the response times that were mentioned earlier and the transaction times against the database, but also things like how well does your JavaScript respond to your user, and things like Google PageSpeed Test. PageSpeed Test? Yes. So is everyone here familiar with PageSpeed Test, part of the Google developer tools? So it's a really nice way of testing your front-end stuff just to see how quickly your page loads. I'm not a programmer, but even I can use it. So if us sysadmins can use it, developers definitely can. And there's a way of automating it as well. It's got an API into it. So you can actually, in your CI pipelines, you can deploy a new version of your code and you can run PageSpeed Test against it and you can get the results back as part of your CI pipeline. And at that point, you've done your unit test, your function test, your integration test, and you've done a speed test to see whether there's any deficiencies that would contribute to the speed that your website's running at. And finally, user monitoring. Oh, there we go, page load speed. Yeah. User journeys. Who here is doing user journeys as part of their monitoring? Yes, man at the back. Really? Okay, cool. So, are you familiar with the concept of user journeys? I'm assuming most of you are, even if it's from as a user, I want to sew that kind of thing, right? There are tools out there that do what we call synthetic monitoring, and you can say, as a user, when I go to this site and I search for a widget in the search box, then I should see 5 widgets come up. And when I add 5 of the first widget into my shopping cart, it should equal this amount of money that it's going to cost me to buy it. And then I should be able to check out with these fake credit card. When I say fake credit card, I mean dummy credentials, not, and it gets passed through to the sandbox and, on Stripe or whatever it is you're using for payments. And you can actually chart that entire journey all the way through your site as if a user was doing it. So there's some great tools out there for doing that. Pingdom will do it. App Dynamics will do it. It's one of the few areas of App Dynamics that I actually like. The rest of it, and then finally, hotspots. So again, hotspots, there are libraries out there that are open source. You can pay for this as part of your monitoring as a service, application performance monitoring type stuff. And it actually shows you where on your website people are clicking, and indeed where on images people are clicking to move through to the next thing. So you can start to build up a pattern of which links that link to a particular page or a particular section of your site are the most popular. Now, as a developer, that's probably not massively interesting, but if you can then take that and give it to your marketing and sales teams and say, okay, let's improve the way this part of the site works, because we've got it loading as fast as it can. It looks exactly as you want it to, but actually you're not getting the results that you want. So let's look at how people are actually using the website, and then let's change the front end. Let's change the way in which we do stuff. Let's offload stuff onto message queues to make things more interesting. Let's send people reminder emails. I'm noticing that over the last couple of years, a lot of websites, if I leave something in my shopping basket, I'll get an email within 24 hours saying, did you still want that? Because it's sat there waiting for you to come back. It's all of these little tricks. And because we can put in the monitoring for all these user journeys and we can find these hotspots, we can start to work with monitoring. I'm going to disappear off on a tangent very briefly. I've spent the last 10 years doing DevOps. Please don't groan. Please don't hold it against me. Okay. DevOps is nothing to do with tooling at all. And I will fight anyone that says it is. Because it's about culture. If you're going to run an efficient DevOps way of working, and it is a way of working, if you've created a DevOps team, you have created another silo, you are not doing DevOps. DevOps is about breaking down those silos. But those silos should extend outside of Dev and Ops. In the most successful DevOps organizations, adopting organizations that I've worked with, we have had marketing, sales, tech support, front end, back end, DBAs, security, and systems administrators working as one team on one feature to deliver that in the best way possible. And the results are phenomenal. Okay. So if you're not working with other departments, if you're still doing, I really hope no one is, but if you're still doing, it works on my machine, it's an ops problem now. Okay? You're not doing DevOps. The best response I've heard to that, by the way, was a developer said, well, it works on my laptop, to which the response was, we'll back up your email, we're shipping your laptop to the data center. Anyway, we'll move on. So, the manual approach to monitoring. Most of you, if you work in a Linux environment, have probably logged onto a box at some point and run these commands. I suspect, especially this one at the bottom, because we all know that a reboot solves all the problems, right? Doesn't give you any idea as to what was actually causing it in the first place. But the problem's gone, so we're all good. So we've got, we're tailing logs, we're grepping for strings, we're running top to see what the CPUs are doing, we're running free to see what the memory is doing. This one here is quite a nice little one. If you're ever wondering whether something's actually running, if you run that on a Linux box, it will give you a list of all of the services that are listening on ports. And it will tell you which ports they're listening on, and it will tell you which processes they are as well. The reason that's really useful is if you're working in AWS, there's a high chance you need to check why your customers can't access your service. And it could be for any number of things. You might have DNS wrong. It might be pointing to completely the wrong place. Your application load balancer or Elastic load balancer might not be configured properly. Your security group might not be allowing traffic in from the load balancer or from the public internet or wherever it's coming from. You might have a host level firewall that's blocking traffic to a particular service, or the service itself might be down. If you jump on a box and run that, you can at least prove the service is up, and then you can check the firewall, and then you can check the security group, and then you can check the load balance, and you can work your way back out. But at least you know the service is running and there's something for it to connect to, as opposed to doing the analysis of all of the infrastructure only to find out that actually Apache had died because of a seg fault. Status of whether the service is running, restarting the service, looking at the journal for the service, and then, like I say, rebooting. So let's look at doing this a bit more intelligently. We want an agent running on the box, ideally. Now, these two here, statsd and collectd. Statsd, most people, I'm assuming, are using or at least aware of. It allows you to just basically pile a load of metrics over UDP from your application or from your infrastructure to a bucket. And every so often, statsd goes, where should I be sending this? Looks at the config. Oh, I should be sending it over there. Off it goes. That could be to Logstash, so it can be ingested into Elasticsearch and queried there. It could be into Influx. It could be into one of the monitoring as a service things. But from an application point of view, statsd is well worth a look. And collectd is something that's been around for years and is actually starting to make a comeback. There's a couple of monitoring as a service providers out there who are now rolling collectd into their stack because it's incredibly flexible and you can configure it to talk to just about anything. So collectd, you can monitor your database, you can monitor all of your Apache and Nginx statistics, you can monitor whether RabbitMQ is running, you can monitor whether Mosquito's running, all of that kind of stuff. There's chances are, if you can think of it, there's probably a plugin for it in collectd. So we've got these agents running on the box, and they're sat there listening, waiting for things to throw statistics at them. Then we've got the data store, which is where they shove everything into, and Elasticsearch and Influx are the two that I tend to use the most. Admittedly, I tend to use them far more for the Internet of Things metrics than I do for application metrics, and I'll come on to why in a minute. But as data stores, they're brilliant. Nice thing about Elastic is that these days, not only have they got Elasticsearch, but Elasticsearch 7, yeah, they keep releasing, it keeps coming out with new major versions. But the latest versions of Elasticsearch will do metrics, and Kibana, which is the graphing interface that goes over the top, it's got some really, really nice visualizations for what I call numeric metrics, as opposed to metrics that you've ripped out of log files. Elasticsearch will also, of course, analyze and search through all your log files, so you can put your application metrics and your system metrics and your application logs and your system logs all in one huge, great data store and query it through the same UI, which is really cool because that means you only have to train people on one visualization tool. InfluxDB is brilliant at time series metrics, like absolutely phenomenal at it, not so great at the logging type stuff. You've got visualization layers. Kibana, like I say, is the Elastic one by default. Grafana will talk to pretty much anything. It will talk to Elastic, it will talk to Influx, it will talk to MySQL if you want it to. You can actually get it to draw graphs directly from MySQL database, or Postgres, or AWS, or all of these kinds of things. People keep writing plugins for it. I think even the BT Red Care alarms, which are the old ones that used to link directly back to the police, you can even query the BT Red Care API through Grafana now. It's just bizarre. So yeah, and then finally an alerting layer. Don't do this yourself. I've run alerting layers, and by alerting layers I'm talking about something comes in at 3 o'clock in the morning where there's an error in your code, or the disks have filled up on the server, or what, you're under attack from whoever, and the alert comes in and it goes to a pager, and the pager fails to send the message. So no one gets woken up. So you don't find out about the issue until 5, 6 hours later, by which point it's too late. You've been hacked, your system's been offline, you've lost business, whatever. Right? So don't do the alerting layer yourself. PagerDuty is probably the most well-known. VictorOps are a close second. Both of them now have low-value tiers, shall we say, in their pricing, where for about $10 to $15 a month, you can have 2 or 3 people on call. Please take responsibility for your code. Please be on call for it. if you deploy, take the pager home with you, or better yet, set it up in PagerDuty so that it's you that's responding to the thing that's broken by your code. And if your code runs fine, great, hand the pager to the next person that's deploying. But from my point of view, I've been woken up so many times at 2, 3 o'clock in the morning, only to have to then ring a developer to get them out of bed, because actually I don't know what I'm doing when I'm looking at their code, and they fixed it without me having to do anything on the servers, that it would have been far more efficient and cheaper for the client if actually we'd just given the pager to the developer in the first place. So play nicely. This is how I do monitoring these days, SCP Fields. Anyone a Hitchhiker's Guide to the Galaxy fan? Know what an SCP field is? Somebody else's problem. Okay. All my monitoring goes to either Datadog or another company called Signal Effects, because you get 5 hosts for free on their basic tier, and then depending on what you want to do with it after that, it's $15 per host per month. All of my alerting goes through PagerDuty, because for a company that's our size, we can get away with the smallest tier. It costs us like $7 a month. Okay. So we install the Datadog agent on every instance that we roll out. It's automatically configured to talk to all of the AWS accounts and DigitalOcean accounts and all the rest of it that we use using Terraform, because they've got a Datadog provider, which is absolutely awesome because it means you've got one code base for all your infrastructure. That's another rant, possibly another talk. And so we have the Datadog agent on there. It's pulling all the data in it, and it's sending it to a dashboard, which I'll show you in a minute. And then PagerDuty is what wakes me up when things break. This means I don't have to run my own monitoring solution. I don't have to worry about whether my monitoring solution is up and monitoring what it's meant to be monitoring. I worked one place where we had our monitoring system, and then we had a monitoring system for the monitoring system. That's very close to turtles all the way down, because you do end up saying, well, what if the monitoring system of the monitoring system goes? Well, let's put in a Raspberry Pi that monitors the monitoring system. Yeah, but Pis aren't really that reliable, so how do just spend the money, man? $15 a month, it's worth every penny for peace of mind. And like I say, with the PagerDuty stuff, we had one mobile phone network we could send the text messages over. PagerDuty used Twilio, and who are now owned by SendGrid. And I think they've got something like 5 different SMS networks in the UK alone that they can send stuff out over. And as well as Twilio, they've got 2 or 3 other providers. So if any of their providers go down, that's fine. They switch to another one, you still get the message. If any of the mobile networks go down, as long as it's not yours, that's fine. You still get the message. So pay them. Just get them to do it. It removes a huge headache. So what do the dashboards look like? Well, this is a very simple one that we've put together ourselves. This is for our Internet of Things platform. We run something called LoRaWAN. LoRaWAN's awesome. You can only send 12 bytes at a time, but you can get about 30 miles as a range on it. So we can fling these gate sensors into farmers' fields. We can track livestock across farms. We can take temperature sensors in rivers. We can do soil analysis and all sorts of stuff like that. And as long as we've got line of sight to where we've put our gateway, which is a bit like your wireless router at home, we can pull the metrics in, which is awesome for us. But there's a load of components behind that. So we've got web servers, we've got message queues, we've got databases, we've got all sorts of other things. So we're running that. This is our test platform, which is why there's not a huge amount going through it. But as you can see, we've got Postgres, we've got RabbitMQ, Redis, Nginx, all the various components of the LoRa server itself, including the APIs. Details about the number of messages going through. It's a particularly busy day here, as you can see. Number of Postgres queries, number of connections, Redis connections, cache performance, all of that kind of stuff. These 2 boxes here, you can't quite read. It says Sentry events at the top and Ansible deploys down here. If we get an error come through on any of the custom Python code or PHP code that we've got running, because something called FarmOS, which runs on top of Drupal, is our front end to this thing, then it comes in here. So we can immediately see the message queues are down. We've got a load of Sentry events complaining about it, so we can start to correlate the metrics with the errors in the code. And when you click on the events in here, it takes you through to Sentry, so you can drill down through the stack trace, which is awesome. And with Ansible, it says, this user ran this role, and that role configured this thing, and all the rest of it. So in one dashboard, we know everything that's going on with our environment, including all of our deploys and all of our errors. Nice thing about Datadog is it also comes with stock dashboards as well. Again, this is a bit squeezed because of projectors and screens and all the rest of it. But as you can see, this is the Docker thing. This is actually for my home server. I've got a server at home that I configure using Terraform. It's running Vault, it's running Console, it's running Docker. It's using Nomad to orchestrate the containers, and it's provisioned using Ansible because I'm sad and I had a lot of time to myself over Christmas. But the nice thing about it is that we can use it for demonstration graphs like this. And so you can see how many containers are running. You can see how many are stopped, started. What the network's doing, what the disk I/O is doing, all of that kind of stuff. And that's all built in for free. I've been talking about Datadog because we are Datadog partners. We are looking at other options because we've found that there's some things Datadog doesn't do that we need it to. I suspect it won't affect many of you here, but trying to get Datadog to run on an embedded device, such as a Raspberry Pi, which is what a lot of our gateways are built from, or even the tiny little, the old WRT54G wireless router type things that are running cut-down version of Linux that's just surreal. Getting anything running on those kind of things is really, really hard. And whilst a lot of the monitoring providers want to work with us, Datadog understandably have said, actually, we can do that and we'll help you do it, but we're a cloud-based monitoring provider. So that's perfectly cool. A lot of our infrastructure in the cloud will remain with them, but I suspect our gateways will probably move to someone else. So that was reasonably whistle-stop. Tour through monitoring what, why, who, and when. I'm guessing you're probably all completely confused as to what should be going on. So I'm going to shut up, and I'm going to ask, are there any questions? Yes, at the back.
How do you differentiate between stuff that gets logged that needs to be investigated immediately and stuff that can wait until the morning?
Depends who your business is. It really does. So it's a really good question. So the question was, how do you differentiate between stuff in your logs that needs to be looked at now, and how do you and what about the stuff that can be looked at later? And one of the things with logging is that it's unique. I mean, system logs are pretty much the same. If you see the same IP address accessing the same URL time and time again, then fail to ban or whatever is your friend there, right? That's a fairly easy one to do. But from an application point of view, you are the person that knows your application best, right? You're going to know which log messages need to be responded to instantly and which ones don't. So when you're writing your logging, when you're setting up your logging library, make sure that the codes, the log lines that get logged as error are actually an error. Make sure the stuff that goes to debug is actually debug information and isn't needed. It is only needed when you're trying to debug the code. It's not part of the day-to-day things. Because if your logs are going into something, Datadog do logging as a service as well, but it could be any of the monitoring as a service, logging as a service providers. What you can usually do is you can set up alerts based on the severity of the log. You can do it based on the string as well, but you can do it based on the severity. And that means that you can say, okay, well, anything that's an error really is an error, and we really do need to get someone out of bed to look at this. And at that point, you just go, well, if you find an error, just send it to PagerDuty. Get someone out of bed. If it's a warning, send it to PagerDuty, but with a lesser priority. And PagerDuty now has the ability to grade warnings that come in. And if it's an error, it will wake you up. And if it's a warning, you'll just get a little notification on your phone. And when you wake up in the morning, it will be sat there. But there isn't, I'd love to say that there's an easy answer to that question, but there really isn't, because it's not, it's system specific and application specific. There will be some that are really common, like I say, like the IP addresses, or what is obviously an attempt to do a SQL injection attack against a version of Joomla that's 5 years old that will never work on your website anyway. But where do you classify that? Because it could be that actually they're just trying to work out which version of Joomla you are running, and then once they've found that out, they'll try an attack that works against it. So I haven't really answered your question, because there isn't really a right answer to do it. But what I would say is, it comes back to what I was saying earlier on about collaborative working. If you're not part of the team that does the log analysis, if you're not part of the team that's responsible for that part of the infrastructure, go and say hi, introduce yourself, talk to them about how you get the logs into their platform, and talk to them about what they think is important and what you think is important, and come to a compromise on it. But, sorry.
Yeah, I have a sort of related question to that. So it seems one of the things I've noticed about using Elasticsearch and so forth for logs is there seems to be an idea now that lots of different logs will be merged into essentially one massive text file, and then we're using energy to almost kind of split it back out again. Like the old way of doing things was having different log files. One of the things I've struggled with a little bit, and perhaps you would have done this in your day-to-day work, is that a bit unreliable, using sort of regular expressions to find stuff, or searches, or greps? It kind of feels almost a bit old world, and actually the old, lots of different log files is a much better idea.
So you're right, it does. And let's be honest, no one really well, a few people enjoy regexes. I don't. But two of you brave enough to volunteer. But yeah, it is awkward writing greps. Elasticsearch has got this grok filter for logstash, which isn't quite POSIX grep, which is different again from Perl, which is different again from PHP regexes. But every language decided to go, we can improve on this, and promptly didn't. And so, but I would still trust those older tools and those older patterns over some of the stuff that I've seen emerging around heuristics and things like that, because we will get to a point where actually all of these logs are ingested by some kind of fire hose, and as they fly through, they are analysed, and they go, that bit of the platform definitely shouldn't be doing that, so we can do this, and it'll all be machine learning or whatever it is. But we're not even close to that yet. And it comes back to, I was saying to the guy just then, is your application. You're the best person to write these expressions that will pull out the important information from your logs. And actually, it doesn't matter whether you do that inside the application and you format it in a particular way. Please don't go down the Java route and do multi-line log entries, by the way. You will be hated by your logging team for that, because they are a nightmare to parse in any way, shape, or form. JSON works quite nicely. Dump a log line out in JSON. We might not be, those of us that work on the system side of things might not love the fact it's in JSON, but we can parse it without any issues at all. But it doesn't matter whether you do it in the application, it doesn't matter whether you do it on our syslog, it doesn't matter whether you do it at the logstash level or inside Elasticsearch itself. At some point, you're going to have to do that filtering. There's no reason you can't do it multiple times, especially for sanitizing important data. So stuff like that, I would say if you can't sanitize that at the application level, then at least sanitize it at the syslog level. So you write it to disk or write it out via Docker or whatever it is, with, well, obviously not the CV2 and the full the full credit card number, but you write out something that might be sensitive information to your debug logs. But then before they get slurped into Elasticsearch, they get replaced with dummy information or something like that. Logstash, Datadog, all the other logging agents, most of them will now do that for you and replace that information. You just need to say, if you match this, replace it with this. And then if you need to, you can get onto disk. But yeah, I would still go down the old route of, I still log to multiple files. Each service has a file. And then those files get collected by syslog, because then they go into different indices inside Elasticsearch. And then you can search across indices and do all sorts of stuff like that. But
feels the industry is kind of going a different way, because it's if Docker can produce several different streams of information, it all has to go through a standard out. Then it's kind of getting squashed together. So then we're having to manually label each error or log in order to find out what it was.
Yeah. 20 years ago, as a systems administrator, I was using something called Norton Ghost, and the idea of Norton Ghost was that you took your application and you packaged it up into a golden image, and then you deployed that golden image to hardware.
We moved away from that model for a reason, and it's because it wasn't flexible enough for us. Docker's come in, I get it. I really understand fully how CI pipelines work. I'm using it on my home server. I've got it running in production. But there's still a part of me that looks at it and goes, but at some point, as you say, We've got to extrapolate all of this information that's coming out and split it into its composite parts, which is the same thing that we did when we introduced Puppet and Chef and Ansible into the systems administration world. It's the IT industry. It goes in a circle. You know, we're still using mainframes. It's just they're called clouds these days. You know. Yeah. How am I doing for time? Okay. Any more for any more?
Talk about logging post data at the beginning. Obviously, there's going to be potentially a lot of data with that on the website, and dealing with volume and also the sensitivity of the data. Obviously, on the password being logged on Facebook. Do you have any thoughts on how to do that properly? Because Facebook can't do it at all, but it seems like it's quite a dangerous thing to do.
It is. Yeah, you've got to be careful. And there's a reason why GDPR and all these other legislation are turning up, right? And it's because, as you say, Cambridge Analytica and all the rest of it, it's just horrific. But it is possible. So first of all, if you don't know what you're doing, find someone that does, would be my advice. That's what I do. I still don't know exactly what I'm doing when it comes to this stuff. When it comes to sanitizing log events and things like that, which is effectively kind of what we're talking about. I mean, you're talking about volume and you're talking about sensitive information, which are two distinct things. For the data volume, if you're throwing it at speed somewhere, throw it onto a message queue. All right, set up something like RabbitMQ or something like that, throw it into there, and then let something process it off the other end, because you'll have the timestamps as the messages are going in, so you can use those timestamps as it's coming out. So you might have a bit of a delay. We've got one of the companies we're working with at the moment's got an SLA of, I think it's something like, the logs have to have left the system and made it into the cluster within 0.7 of a second, something like that. But actually that's doable. So that's fine. But if you're going to sanitize it at the same time, you've got a processing overhead there. And I would do that before it hits the message queue.
I think post data is particularly dangerous. These generic systems are not going to know your system. No. So it's not going to know that the PWSD field, because you just typed it, is going to be sensitive.
No, it's not.
And if you're throwing that data around, because one thing I quite like about post data is it goes into memory, it's processed in the PHP world, and it's pretty much dumped, it's gone.
Right.
And you don't have to worry about it finding it in the wrong location somewhere. It's just you mentioned it.
So maybe in that case, I said at the beginning, I'm not a developer. Maybe logging post data isn't the right thing to do. Maybe it's logging the variable values of that post data as opposed to the raw post data itself. I'm going to come back to my get out clause, which is it's your application. And the main reason I keep coming back to that is because I've had so many security teams say to me, well, it's your application. It's your platform. We can't tell you how to secure it. We can tell you when it's not secure, but you need to know how to secure it. And it's a similar kind of thing. Monitoring is incredibly subjective, which is why it's not a solved problem yet. We've had monitoring sucks as a hashtag trending on Twitter for the better part of 8 or 9 years. It's still not fixed. It's a lot better than it was. I am so glad I don't have to deploy Nagios anymore. And for those of you that have worked with Nagios, you will know my pain, especially when you start to scale it out to 4,500 physical hosts. It doesn't work. There's no back end to it. It's all flat file configs. It's awful. But it's your system. You need to understand it. You need to make sure of it. And this kind of comes back to what I was saying about Docker as well, is that the great thing about Docker is that you guys can write it on your Macs, your Windows PCs, your Linux PCs, your laptops, whatever, create a container, and you know that it doesn't matter whether you deploy that to Kubernetes, to Docker, to Nomad, whatever, it will run. And you can put a load balancer in front of that, and it will run, and that's awesome. But what you're losing, and I mean this in the nicest possible way, is an understanding of what's happening underneath that container. And many developers that I speak to, possibly quite rightly, say, but we don't need to know what's happening because that's somebody else's problem. It's the infrastructure team's job to keep that running. And most of the time they're right. But if you understand a little bit about what it means to run Docker, if you understand a little bit about what it means to actually set up a Kubernetes pod, and run that yourself. To understand the infrastructure that you're actually deploying to understand what that's logging, to understand how you log to it, to understand all the metrics involved and stuff like that. It means when you get that phone call at 3 o'clock in the morning that says your container's gone down and we don't know how to restart it, you can say, oh, no, I saw this about 3 months ago and I thought it was a one-off. But actually, if you go into Kubernetes config and you tweak that flag, set that flag to that, then that should do it, because what you're doing is you're replicating the exact issue I've seen. And because you know the underlying thing, you can work with the ops teams to fix it. You can work with the ops teams to analyze the logs. You can work with the ops teams to analyze the metrics. You can build better dashboards for people. You can build better dashboards for the business. And what do the business love more than anything else? Pictures drawn in crayon. Give them a single screen that says, this is how much money we saved this month, and this is how much money we made as a result. And if they click on it, it takes them back to Git commits or log entries or whatever that prove that. Then you will notice a significant shift in the culture of your organization. And they will come to love you, and they will come to work with you, instead of just saying, oh, bloody developers over in the corner. So yeah. Anyway, again, I've not answered your question quite, because the answer is, it's your application. You know, you run it, you support it, kind of thing. And yeah. So there endeth the rant.
Alex, well, thank you very much.